In this video, we have two integrals to evaluate. So let's look at number one. Which method would you use? This can involve more than one method as usual. U-substitution, integration by parts maybe. Can you see which method would work? Is there one that's obvious to you? Well, if you look at what's in the parentheses here, ln of x, the derivative of ln of x is 1 over x. You got a dx right there. So that right away tells you that a U-substitution should work. So let u equal ln of x, then du would equal to the derivative of ln of x, which is 1 over x, and then this would be dx. Now let's try to transform this integral into one involving the variable u. The ln of x, of course, will be uu. The dx over x would be du. Well, let's take it from right there. Be the integral, and this should be u squared, because ln of x is u, and then you got the square there, and then dx over x, that's your du here. And then we integrate with respect to u. Add 1 to the exponent, get u to the third, you divide by that, then it's plus the constant of integration. And then we always go back to the original variable. U was equal to ln of x. Let's put the ln of x here. We can put the cube here, or we can put it in parentheses and then cube it. Either way, we get ln to the third power of x over 3 plus the constant of integration. Now for the heck of it, just go ahead and check this one. Got this to a power of 3, so that's 3 comes out in front. 3 and 3 cancels, then you subtract 1 from the 3. It gives you ln of x squared. And then with the chain rule, you take the derivative of ln of x, and you get 1 over x. You get this. You get that integrand back. So again, the check, 3 in front, 3 and 3 cancel, subtract 1, you get 2. That gives me the ln of x squared. And then because of the chain rule, we take the derivative of ln of x, we get a 1 over x, which of course is what we have there. For number 2, I'm going to try letting u equal to x plus 1. When in doubt, go with the U-substitution. So du would equal to the derivative of x plus 1, which is 1, so this will be just dx here. So we have equals here then, the integral of, notice, du and dx are the same. So for the numerator, I'm just going to put a du here. The denominator, the x plus 1 is u, so this will be u, square root of u, or if I write it as u to the 1/2. Simple integration now with respect to u. Take this upstairs, becomes the negative 1/2. And we just add 1 to the exponent of negative 1/2. We get a 1/2, u to the 1/2. And then we divide the coefficient 1 by 1/2, we get a 2. And then it's plus the constant of integration. And then we go back to the original variable. We just replace the u by x plus 1. So this will be a 2. And I'm going to write it back as a radical, since we started off with a square root here. So this will be 2 times the square root of x plus 1, plus the constant of integration. That's your final answer for that one. Now if you want to check this one, got x plus 1, this will be 2x plus 1 to the 1/2, so general power rule, the 1/2 comes in front, that becomes 1/2 times 2 is 1. We subtract 1 from the 1/2, that gives you a minus 1/2, so that goes down to the denominator as the square root of x plus 1. But chain rule tells me I take the derivative of x plus 1. Now here it doesn't matter because the derivative of x plus 1 is 1. So I'm still going to get this integrand. So final answer, 2 times the square root of x plus 1 plus the constant of integration. Thanks for watching. We'll see you next time.